So we'll talk today about triggers in a database system. We'll talk about creating triggers. There's two types, there's the statement level and the row level. And we'll talk about firing triggers, and then at the end we'll also talk about events, which are very similar to triggers. So here's kind of the motivation for it. Suppose we designed a database table, a database system that has two tables in it. And one table is called members. So we have a member ID, which could be an email. Usually emails are the member ID. Person's first name and last name, and maybe their date of birth. And then suppose we decided to have the passwords put in a different table. We could always have a password column on this first table, but maybe for security reasons, we decided to have the members' passwords written in a separate table. So when we go to delete a member, so let's say somebody joins, Facebook, and then they've been a member of this website for a while, and then they decide to leave. So suppose we were to issue the command, the SQL statement, to delete the member. Well, one thing we wouldn't want to have happen is to delete the member, but leave that password on it. Like we forgot to leave the password. So what we might want to do is say, anytime we are going to delete a member, if that same member ID happens to have a password, we should get rid of it. There's no point in having this member's password is this, but the member doesn't exist. So we might want to set our database as a protection in such a way that if anybody tries to delete a member, we will, prior to them deleting the member, we'll delete that password. And they may not have a password, which is okay, but if they do, we'll get rid of it. So that'll guarantee we don't have any, old passwords laying around. So what we can do is, now we can't control, we don't know when somebody's going to come along and delete a member. Some member has to log in and say, I want to leave this website, and they hit delete me. So we can set up our database so that it's ready. Anytime somebody goes to delete a member, we will first delete that password from a different table and then let their record be deleted from the members table. So what we'll do is we'll set up this, I don't want to use the word event because that's a different thing, but this is an event that will happen anytime someone deletes a member from this table. So we call that a trigger. It's like a gun ready to fire. It will be fired as soon as someone tries to delete a record from the members table. We will delete the corresponding record from the password table. So the data definition language, the DDL for a trigger is, we would say create trigger. We'll give it a name. We'll call it, delete password of deleted members. That's what this trigger is doing. And we'll say we'll do it before. We could do it after, but we'll say we're going to do it before. We can say we're going to do it we'll say before delete on the members table. Now this row, by saying for each row, means we'll do it every time a row is changed. If we don't have this line, that means it happens once when the table is affected. But this is going to be on a per row basis. So we could say, then we're going to actually put our action in. What do we want to do? And we're going to say delete from members' passwords, delete from this table, any record where the member ID equals the member ID that is in the process of being deleted. So what this would do is now, anytime somebody goes to delete a member, we will always, before that happens, the database will fire this trigger. We'll delete the password first, and then second, the member would be deleted. So here's the overall syntax of the trigger. You create it. You could decide you could put yourself down as the user. You say trigger, you give it a name, and then the trigger time event, we'll talk about that a little bit later. You could say on a particular table. You have the option to say for each row, so it could be when anything happens to the table or anything that happens for every row in the table. That's up to you. You could decide if it's before, during, and after, when it happens. And then you describe what is happening. And but basically what we're doing in that last example is we're just updating another table, we're deleting from another table. So in here, you could have some SQL statements. If it's a lot of stuff, we could put a begin and an end statement and have like a whole program that runs. And then you can have the time, the event, and the order. We can get into a little bit later. So, but anyway, that's the overall syntax for how to set up a trigger. So here's an example of what they call a statement level, not per row, but per statement. We could say create. Now we also have this thing called, this optional thing I'm sneaking in here called or replace. If you go to create a trigger and the name of the trigger already exists in your database, you're going to get an error saying I already have that trigger. And it's not going to say, would you like me to replace it with this new one? So if you say create or replace, that means if it's already there, overwrite it with this new one. Okay, so create or replace trigger, and the name of the trigger is someone is doing an update. So I'm going to say after update on the accounts table, and now I have a few things I want to do. So I'll put a begin and an end statement that you'll have to do. And I'm only doing one SQL statement, but I could say insert into the update log. So I have a table called update log. I could put in an event and a timestamp. So I could put in some kind of an event, and I'll give the value that the event is someone is updating again. I just put in a sentence, someone's updating again. And then I take the system time, what time was it? So basically I'm just keeping a record on this table. Anytime someone does an update to the table, I run this trigger, and it just runs once for the whole table, not once for every row. Okay, so this table would be fired once after the following data manipulation language is entered. So if somebody came along and said update, because we're only doing it after updates, if someone said update account, set balance equal to balance times 1.01. So it looks like maybe they're giving 1% interest to every account. After all of that, let's say the accounts, there's 1 million accounts in our table. We're going to give everybody 1% interest. And then after that, one time, we're going to say someone is updating again, and just put a timestamp. So it won't get fired for every account. You're not going to get this coming in 1 million times. You'll just get it one time because it's a statement or table level trigger. A row level trigger, that means a trigger that runs every time a row is changed, not every time a table is changed. We could say create or replace. Trigger, we give it a name, log updates. After update on accounts, I'm going to now say, so I kind of highlighted this, for each row. I want this trigger to run every time a row changes in the table. I would say begin and end again. Insert into the log an event and a timestamp, and then say someone is updating the account with that timestamp. This trigger will be fired for every row in the table, so if there's 1 million records, you're going to log this statement 1 million times. Okay, yeah, so let me kind of just recap that. So if I say update accounts, set balance equal to balance 1 plus 1, and I don't have a where clause, where the user is equal to you, this would mean it would do it for everybody in the table. So if we assume that there's 1 million accounts, 1 million rows, the statement level trigger will be activated once, the row level trigger will be activated once for every row, which means it will be activated 1 million times. Okay, so suppose this was our table. So this is our table. We have an ID, a name, and a salary. And it looks like student salary. Okay, but anyway, this example of salary is a lot, but okay. So suppose we said create or replace trigger, display salary changes. So every time someone's salary is changed, maybe we don't have to always update a table. We could also just print out something to the database administrator. So we could say before, delete, or insert, or an update. So if someone is deleted, a new person is added, which is an insert, or an existing person has their values changed on this employees table, for every row, when the new salary, when the new ID, what we're changing to, is greater than 0, then what we'll do is we'll have a variable called, salary difference, which is a number. So we could take an integer or a real number. And we're going to do a little bit of a computation. So now this begin and end is going to actually have some meaning because we're saying we're doing multiple things. So we're going to say the salary difference is, now triggers will cause, anytime a variable changes, we're going to have the old value, what it was before the change, and the new value, what it's going to be after the change. And they're assigned to the variables new and old. So new dot salary minus old dot salary is the difference in the salary. So we're doing now a computation. And then we're saying now this is going to be different from database to database. So this is database management system output, but this is to send to the database administrator. We could say the old salary, this is a string, and then say old dot salary, what the salary used to be. And then we could say the new salary, what the new salary would be, print out what the new salary is, and we've calculated how much it's changed. We could also say what the difference is. Okay, so let's say this was our original table, and we went and we created this trigger. So anytime, now if somebody changes a person's, well, nobody changes their name, but suppose someone changed their name, put in their first name and their last name, would this trigger go off? No, it wouldn't go off because, well, if the ID, let's see. Yeah, actually it would go off. You should have said only on changes to the salary, but okay. So anyway, so now suppose we'll make an example. We'll issue an SQL statement that will change somebody's salary. So here what we're going to do is we're going to input, we're going to insert into the table. We have these 3 columns. We insert a new person into the table. Now what this trigger was saying is anytime you delete a person, insert a row, delete a row, insert a row, or make a change to a row, anywhere in the employee table, we're going to go through this. So we're now inserting into the table. So we're going to look at what the old salary was, and what is the old salary for this new person? There is no old salary, right? They didn't exist before. So their old salary ends up being blank. Their new salary is whatever the new salary is. And then the difference, we couldn't do a computation between blank and 7,500. You might argue blank for a numerical value should default to 0, but they don't do that. So since the old salary was undefined, the difference would be undefined. So the database administrator would get a message like this, which is basically letting you know a new person has joined the website. So suppose somebody wanted to give a raise to employee number 2. This employee wanted to give a raise to this employee. And they said update employees. They issued the SQL statement. Update employees, set salary equal to salary plus 500, where the ID equals 2. So for this row, take whatever value this is, add 500 to it, and write that value back. So 2,000 would get written here. The database administrator would get a message. So, the database administrator wants to know, is someone playing around with salaries? I got to make sure it's legitimate changes to the salary. So it would say the old salary was 1,500 and the new salary is 2,000. The difference is 500, and you look at that and go, oh, that seems okay. So these are this is kind of, triggers can be used for monitoring. So this is the triggers, for displaying these values. Okay. This is incorrect. So there's an error in the slide, so I'll fix it. So let's figure out what is the error in the slide. So we go to this is way off. If we're deleting, let's change it right now. If we're deleting somebody, if we're deleting number 2, the old salary is $1,500, the new salary doesn't exist, and the difference doesn't exist. So I shouldn't have done that. That's a copy and paste error on my part. Okay. Okay, so, okay. So if we go to delete employee number 2, and that, well, that last example, the salary change didn't take, let's say. Okay, so now we're saying the old salary was $1,500, the new salary doesn't exist because the person doesn't exist, and therefore we can't calculate the difference. So that's kind of strange if you think about it. This is kind of a strange trigger to tell you, we want to tell how much the salary has changed. I don't know if it even makes sense when a person's deleted or inserted to tell what's the difference between the old salary and the new salary. In one case, there is no old salary, in the other one, there is no new salary. But in either case, it's just showing how you can set these up, set these triggers up to run. Okay, now what other examples might we use a trigger in a database? So a trigger is not, people come along and are updating the database all the time. You might want to keep some statistics about updates that are going on. So you could have a trigger that says, this might be a useful trigger if you have an online store. You could say create or replace trigger, price history trigger. So before an update on the price on a product, before somebody changes the price of a product, for each row, so it's a row level trigger, I want to insert into, let's say I have another table called product history. I want to insert the values of the old product ID, the old product name, the old product supplier, and what is the unit price. So what this is basically doing is every time somebody logs into your online store and changes the price of a product, any product, before that happens, I want to take the current price and copy it into a log that says this is what the price used to be. So if you had, let's say you're selling sweaters, and the sweaters were $20, and then you made them go up to $25, and then they went on sale for $15, and now they're back to $25. Every time someone made a change to the current price, you kept logging all the changes. So now you know it went from 20 to 25 to 15, back to 25, and on what date. I didn't put the date. I should put the date there. So it was good to find out when you did this stuff. But anyway, so this is so we have a table called products, and in the products there's a field called price. And that, if someone logs into your online store, they see the current price. All they know is the current price. If someone comes along who works for your company, changes the price to a new price, if for some reason you want to keep a log of the old prices, you set up a trigger. And the trigger will write into a different table called product price history. So that would list out all your products and every time the price has changed. And you just write the old price. The database products, the table products has the current price, and the history has all the previous prices. So the person changing it doesn't have to remember, oh, I have to log the old price before I change the new price. Just set up a trigger and then it'll take care of it for you. Okay. So then there's the concept of cascading triggers. Since a trigger's action could be to update a table in your database, we can have trigger T1 updates a row in, let's say, the product's average price whenever product price changes. So suppose we had something that's keeping what is the average price of all your products. Let's say someone logs into your website and you say, we have 10 products and the average price is $20. Well, if one product changes, that's going to cause your average to change. So you set up one trigger that says anytime someone changes the price of an item, the average price changes. Then somebody inserts, let's say trigger 2 inserts a new record into the logging the average price changes whenever the average price changes. So now what we have is if someone changes, so now we have two triggers. Someone changes the price of an item, you update a table, you update a field that says what your average price is. And every time the average price changes, you keep a log of it. So if somebody changes the price of any item, that causes trigger 1 to run. And when trigger 1 runs, that causes trigger 2 to run. And you can do this, we could do this over and over. Trigger 3 runs, then 4, you know. So since triggers can update tables, and then there could be a trigger on that table that could be a series of triggers that run when you update one table. So that's called a cascading of triggers. Okay, so in this case, the update of product price will cause a trigger 1 to fire and update a row in your product's average price, which will cause trigger 2 to fire and insert a log value, logging the change in prices. Okay, so one thing we don't want to do is have a situation where, let's say we have trigger 12 changes table 2 whenever table 1 changes. Trigger 23, so table 2 changes table 3 whenever table 2 changes. So this is a change to table 2 triggers table 3. That's where these numbers come from. So a change to table 1 triggers a change to table 2. A change to table 2 triggers a change to table 3. And suppose you had another trigger that every time table 3 changes, you change table 1. What would happen if anyone updated any one of these tables? They would just keep updating themselves. They would go into an infinite loop, right? So we never want to have a cycle, a cyclic cascade in trigger. So this would be known as recursive triggers. Wherever a trigger calls a sequence of triggers that causes that trigger to run yet again. So those are called recursive triggers. Now, depending on which database you're using, if you do this, you're just going to go into an infinite loop and the database will close. You have to be careful. Other ones, you can actually say, don't allow recursive triggers. So if somebody put these triggers in, the last one would get blocked. It would detect that you created a recursive trigger, won't allow it. And other ones will actually let you set how many levels you want to go. Like, you'll do one round of, this one triggered this one, which triggered this one, which got back to this one, and after one round, they stop. So different databases handle it different ways. I guess it's more important we just know what the issue is here. Okay. So now that we're introducing the ideas of triggers, there's an interesting concept. You Google this, triggers versus foreign keys. Interesting to tell us about this. So you remember when we talked about in SQL, we talked about what foreign keys are. So a foreign key was if you had a field in a table and you wanted to insert a row into the table, but only certain values for that column make sense, and the only ones you accept are ones that appear in another table. So for example, suppose we had a table called members. We have members, so there's a member ID, a first name, a last name, and a password. And then we have another table, all the tweets that that person makes. So, I guess this would be something like Twitter. That's it. Facebook, we're doing tweets on Facebook. All right, but anyway, suppose now we have a separate table, all the comments a person made, all the tweets a person made. So we would want to know the member ID, what their tweet is, and then maybe what time they did it, so we could sort the most recent tweets at the top of the list or something like that. So it wouldn't make sense for us to add a row to the tweets if the member ID is a person who doesn't exist, right? If you have a website that's collecting people's tweets, why should a person who doesn't exist make a tweet? Only people who exist should make a tweet. So if we go to write into this table, we would want to do a check. I'm writing in the member ID, the message, and what time they made their tweet. But if the member ID doesn't exist in this table, then I shouldn't record it, right? You don't want, anonymous people making. So when you create a foreign key, when you create this table, you say, you know, create table tweets, and then you list out all the columns, and you know, this would be 25 characters, and this could be 142 characters, or whatever Twitter allows, and a timestamp could be 25 characters. And then at the bottom you would say, and I want to create a foreign key. I want the MID to be a foreign key to the table members on their field MID. So the only acceptable values you can put in here, at the moment you're trying to write into the table, we're going to do a lookup in this table to see if we find that person. And if we find that person, then I'll let you write the tweet. That's a foreign key, right? So that's a little review of what we talked about with foreign keys. Now, if you set up something as a foreign key, and you go to delete that member from the members table, but they've made a number of tweets, and now you're gonna delete the member, what would happen if you went to delete a member who had this tweets table was created with a foreign key? So I can only put rows in this record if this person, this member ID exists in this table. So when I go to delete the person, what would happen in our database? The rule, when you created this tweets table, you said only tweets from people who are in this table can exist in the tweets table. And they got in there because the person was tweeting while they were a member. That's how they got in the table. Now they want to delete themselves from the table. Can they delete themselves if they were a foreign key? Or would there be an error? The database would say, sorry, you can't delete that person because they have tweets. You'd have to delete all their tweets first. Then you could delete that. So do you guys know, like on Twitter and Facebook, if you know anyone who's ever created a membership, did some tweets, and then deleted their membership? Do their tweets go away?
Yeah. Yes.
They go away?
Yeah. They're not there anymore.
They don't. Well, what if that's strange? What if you're in the middle of a conversation with somebody?
It just goes through.
Like one person who is a member says one thing, and then you gave a response, and then they replied to you. Now you go away. What happens?
My comment will be deleted.
What?
My comment will be deleted.
Your comment, but the other persons will still be there.
Yeah.
Then it's like they're talking to themselves, right? Is that how it works? Oh, maybe I should create a account, do some tweets, and then delete it. But well, so that would look strange. That log, it would be now a conversation between one person, and the answers are missing, right? I don't know. All right, so this is probably an issue they'd have to deal with. But suppose we wanted to create our website in such a way that if a person became a member, first thing they do is become a member. Once they're a member, they start making tweets. And we want to let them make tweets, but if they want to delete themselves, but we wanted their tweets to be around after they delete themselves, we'd have to make them sign some agreement that says, if you start doing tweets and then delete yourself, your tweets stay around. Something like that. So, but let's say we wanted to design it that way. We wouldn't want to put a foreign key restriction here, because we'd like to actually let the person delete themselves but leave their tweets around. What we could do instead of a foreign key is we could create a trigger that anytime somebody writes to the tweets account, at the moment they're writing it, our rule is they have to exist. They have to be a member. But if they later leave, we'll leave the tweet around. If this is our design, then instead of using a foreign key, what we would do is create a trigger that says anytime someone adds a tweet, the first thing I want to do is check, does this person exist? If so, I'll add the tweet. If not, I'll say, you know, this person doesn't exist, no tweets allowed. And then if they later on delete themselves, because there's no foreign key constraint, they can just delete themselves. The tweets will stay around. And any future tweets from that person who's now deleted would get blocked by the trigger. So there is so now it's a design issue. What do you want to let into tables, and then once stuff is in, do you care that the foreign key constraint went away? Okay. Okay. And then events are, so I kind of just throwing this in at the end. An event is like a trigger, but doesn't fire, it doesn't sit around waiting for someone to update a table to wake up and start running. It runs against a certain time. It's just, it's like a trigger. It, you know, updates your database or does really whatever you want, but it happens at a certain time. So, so for example, we could say create event, give it a name, and we'll call it backup the database. And we could say on schedule every 1 hour, starting at the current timestamp, whatever time it is now, as I enter the event, and then I say every month. The interval is every month. And when does it end? When the current timestamp plus the interval of 1 month plus the interval of 1 week. So it would be, so this would start a month from now, and it would run for a week, a month from now plus 1 week. And the backup would run every hour. And then what I have to do is actually put in the code that actually reads every table and writes to backup tables. So then I'd say do, and I put all my instructions here. So to back up an entire database, you probably want to, for every table you want to have a corresponding table probably called backup underscore the same table name. And you just keep copying all the contents of one table over to the other. So here we're setting up a trigger. It's not really a trigger because a trigger runs whenever the database changes. Then the trigger runs, either before it or after it. This is an event that runs against the clock. It looks at what time it is and then starts issuing SQL statements. And so an example might be like an event during some downtime. You want to do some backups in the middle of the night. So you could say, let's say you have a big website like Facebook, Twitter, you know, has over 1 billion members, and every day a couple thousand join. So every time someone joins, you don't want to add them to the members table because then you have to update all your indexes, which would take a lot of time. So maybe you have a separate table for all the people who joined today. So you have your members, which is 1 billion people, and then you have today's members. Maybe that's a separate table called today's members. And that has 2,000 people. How many? Anyone know how many people join Facebook a day? Anyone have? All right, that's probably something worth Googling. So now when you go to look for somebody, you look for them indexed through the members table, and if they're not there, you say, oh, maybe they joined today. And you look for them in the small today's table, and then you find them. Then maybe at the end of the day, at 3 o'clock in the morning, well, you know, Facebook's worldwide, so there is no 3 o'clock in the morning. But some inconspicuous time. We could then take all the new members and copy them into the regular members table and recalculate all the indexes. So we would rather schedule an event than a trigger to do that. So we could say, create an event called add today's members on schedule every day, and we can say starting at 3:20 a.m. in the morning, and then we could say what our code is. We could disable our index, you know, this is just comments, but the code would be disable our indexes, add the new members to the members table, and then recalculate all our indexes and then reopen our database. So again, so all really an event is a trigger that runs based on a time of day, whereas a trigger is an event that runs every time the update you specified to the database happens.